Hi, good afternoon. Thanks everyone for coming. I will present today on Pattern, which is essentially an open source project for migrating existing models and basically be able to score them onto Hadoop. I work for Concurrent, the company behind Cascading, and also the Pattern and Lingual projects. Before I start, I'll do a quick poll of hand. How many of you have heard about cascading or scalding? A couple of you, half of you, okay, great. I'll just start, in a nutshell, to explain what Pattern is, to clarify. It's essentially an open source project, part of the Cascading family that runs on top of Cascading, right? And essentially, it allows, to reuse existing PMML models that have been exported by tools like R, SAS, and MicroStrategy, and run them onto Hadoop, through cascading. So run them at scale onto Hadoop. And essentially, the model are reused and deployed, within cascading workflows. So I'll spend some time today still talking about cascading because I think it's important to understand what it is because the core of the platform relies on that. And then I'll explain, cascading and PML fit together, talk about examples of scenario for deployment, and then I'll do a demonstration. So for those of you who haven't heard, about cascading, it's essentially a popular application framework to develop, data management, data analytics applications at scale. And it does so by abstracting the development, right, by relying on software patterns. And essentially, the idea is that you focus on business logic, and it makes, the creation, testing, deployment, and operations of the application a lot easier, right? By essentially providing a high level of abstraction. Cascading essentially runs on top of a number of compute platforms. So we can run, in memory for local development. In the future, we'll be actually improving the in-memory for more production. And then we also run on Hadoop 1 and 2 with map and reduce. We're also in the process of analyzing, the Tej report. So we'll be running on Tej also very soon. And in the future, we kind of announced that we'll be looking at also additional fabric like Storm or Spark. So the idea there is we'll be able to kind of use the same application framework and be able to deploy on different fabrics. From a high-level standpoint, we basically have customers who choose to deploy, in-house, right, and on-premise, right? And we have a number of, users who do that, on the cloud. So we have a few partnerships there. We have lots of deployment on Amazon EMR, but also on partner platform like, Qbol, Alsyscale, Rackspace, and so forth. At the core, we essentially, again, an application framework. So we sit on top of, Hadoop distribution. So we essentially have, compatibility test suite. And we certify basically with all the Hadoop vendors, right, including, Hortonworks, Cloudera, Mappa, and so forth. We do integrate with a number of essentially systems out there, right? So we essentially have adapters, right, for systems like, relational databases, NoSQL, NewSQL, systems like, Elasticsearch, Memcache, and so forth. And cascading essentially framework sits on top of that, and you essentially build your application on top of that. On top of the framework, we have a few other, projects. So Lingual adds NZSQL support to cascading. So we have an NZSQL, parser, on top. Pattern, which I'm going to be talking more about, essentially adds, PMML support for scoring models. And then there are also what we call domain language specific extensions to cascading. So scalding is a popular one, developed by Twitter, where they essentially did a Scala language binding, for cascading called scalding. And likewise, there's a project called Cascalog, with closure support. So the technology is being used, quite a bit. We literally have, thousands of customers deploying in production. So we got some pretty large, users, out there that are deploying, in the thousands of nodes, right? So we're just, quoting, a few of them. Twitter is a power user. They are as actually a big contributor also on the platform because they basically develop, the scalding, APIs. So they, for instance, they do all the revenue apps at Twitter on top of Hadoop, /scalding. Climate Corporation is an interesting example. They really only started a few years ago, and it's kind of a pure, data player, right? It's a great example of a big data company that went from like, zero to like almost $1 billion when Monsanto acquired them, right? And what they do, they essentially in the risk insurance, business. So they essentially look at gathering a number of data sources, including data from farms, tractors. Then they essentially correlate that with agronomical models that they have, and they actually correlate that with essentially weather data, and then they can do predictions based basically on how likely it is that there will be issues with a particular crop based on weather patterns, and lots of other folks that are using our technology. So it's kind of a little bit across the board, right? There's not one area with a pure horizontal middleware solution, right? But because there are more and more new types of data, whether it's log, click streams, sensors data, and so forth, we see more and more use cases. And essentially, the technology originated over 7 years ago when Chris Wenzel created Concurrent, the company. So there has been lots of developments over the years in different market segments, and now we're seeing also the typical Fortune 500 for like healthcare application, banking application, using the technology also. And I didn't do an intro here, but the technology cascading is also fully open source, right, under Apache v2 license. Just kind of zooming in a little bit to explain people what it is, to kind of give a little bit of a feel of what actually is cascading, right? So it's based on a metaphor of flows, right? So essentially, you have tuple streams, flowing through. So they're essentially set of data records. So you can look at the tuple as like a data record, similar to database, but it can have a very complex structure. It can be like a JSON document, for instance, right? And you essentially have streams of those tuples, flowing through, and they're kind of, directed and processed through a pipe assembly, right? So the pipe assembly will redirect, those tuples appropriately, and then the pipes will perform operations on those tuples, and you can perform operation on individual tuple or operation on group of tuples. So in the end, what you end up doing, you end up, defining what are the sources of information, where are the streams coming from, and we have the notion of source tap. And then you start, directing, that and processing that through essentially a directed acyclic graph, which is basically your pipe assembly. And in addition to that, when you get a tuple stream, you basically have the option and you can essentially annotate that tuple stream using the concept of fields. So basically, if you have a simple, for instance, Apache log file, you'll apply a function to parse that into a few fields, right, based on like IP, request, size, and so forth. And then from there, you can start manipulating the stream using fields, so using logical operation at high level, and using also higher level constructs like splitting, merging, filtering, transforming, grouping, aggregating, and so forth. And then in turn, you can have as many sync tabs, which basically output the data to different systems. And there again, we use essentially the adapters we have, whether it's like file, HDFS, Elasticsearch, Memcache, relational database, NoSQL database, and so forth. And the idea is that using cascading, you can make it really easy to kind of create those very complex workflows, right? So we have some customers that are creating flows, right, with like hundreds of pipes in them, right? So very complex, very operationalized workflows, and workflow that will run daily, multiple times a day, and process essentially terabytes of data. And with the framework, you have lots of constructs also allowing to make it very robust. So you have a notion, for instance, of being able to create assertions where you can verify the quality of individual tuple, individual data records, and based on those assertions, you can decide if you have an exception, what to do. You can ignore the data, or you can put it aside. You can even fail the process, right? And likewise, if you have exceptions, then you can basically decide what to do with the exception. You could fail the process, you could ignore it, or you could redirect it to a particular tap, and then decide what to do with it. So it makes kind of the complex flows kind of easy to do. And so at the end of the day, once you model your pipe assembly and you connect the source and sync tabs, it becomes something that's executable. It becomes a flow in cascading terminology, and a flow is basically something you can execute. in the Hadoop cluster. In addition to that, there's also the concept of cascade, hence the name cascading, where you can take multiple flows and you can start chaining them and create dependencies within those flows, right? The idea there is that if you have a complex set of flows, and you might have some of them that run every 24 hours because they do high-level aggregation, and some others that run every 2 hours, right? But you still need them as part of the overall cascade process. Then it kind of behaves like a makefile, right? So you can keep executing the flows that that are already up to date. So it kind of saves a lot of time for those complex chain workflows. Just a little bit more on cascading. So essentially, once you write in cascading using the construct of like types and pipes, it's kind of like independent from the execution environment, right? At runtime, when you run the app, there's going to be a planner that's going to be verifying essentially that the graph is okay, meaning that there are no holes or no things missing as far as like fields that you don't use it, right? So it's kind of the notion of fail fast, right? It will detect right away, and as soon as it detects that it can actually plan for the graph, it will create basically an execution plan, right, for the platform. And currently we have 2 planners, right? So you can develop locally. So typically you can develop and deploy locally. So typically it will be much faster to do all the development locally, right? And then transparently, once your application is tested and developed, then you can switch to Hadoop cluster. And again, we support Hadoop 1 and 2 map and reduce, and we're adding tail support very soon. And the idea is that essentially the plane maps the application in a deterministic way. So at the end of the day, it kind of looks something like that, right? If you have a very simple flow, with a few steps, in that case, we're getting 2 source tabs, and we're applying functions, and we're applying, essentially, group by and kind of like a join operation, right? And then we're doing any number of functions. In the end of the day, the planner will decide on how it translates from an execution standpoint based on the platform. So if it's map and reduce, if it's Hadoop, it will be, and if it's map and reduce, then it will map into a number of mappers and reducers. And I will show you what it looks like, using a tool we have. So at the end of the day, this is kind of what it looks like. For instance, this is some code in order to do a top 10 IPs for Apache log file, right? This is the Java flavor. So Java is typically, a little bit more cumbersome, right? Than if you were to do that in a scolding, right? It's a bit more verbose, right? But here you can see that we're defining a regex parser. We're using a regex parser function. We're going to parse that file into IP, time, request, response, and size, because these are the fields that are available in that Apache log file, standard log file. After that, it's regex, right? So it's kind of like looks complicated, but this is pretty standard in order to be able to parse log files. And what it's basically saying is like we're going to use all 5 fields and parse that query essentially in those 5 fields. And then the next line of code with the each, it's basically saying we're going to apply for each tuple within that data source. We're going to basically do it line by line. So by default, based on the tap we're using and the scheme we're using, it's going to read line by line. And we're going to apply the parser for every single line, and we're basically getting the results. I'm not going to go in depth there, but there's a notion of field algebra where you can combine the input and the output. So in that case, we're essentially computing a function, and we're saying, give me the results. Then after that, we decide to group by IP. So we create, essentially bags, for every IP in that tuple stream, right? And then for every bag, we're essentially going to apply, a count function, and we're going to create a new field called IP count. So now in the end, what we had out of that, we essentially have groups, for every, IP, and we know how many access counts, there are, right? And after that, what we do, we group by IP count to essentially sort now by IP count, and then we apply a function to limit, the top 10, to limit and get the top 10. So it's kind of a way, to do, the top 10, in kind of cascading, mindset, right? It's still, kind of procedural. We could also do a similar query if we were to use a lingual, right, which would be like in the SQL. But in cascading terminology, this is kind of the way you do it. And again, you don't have to think about low-level stuff in map and reduce. We now have a tool called Driven, and I'm not going to talk too much about that, but if you're interested in the exhibit area, we actually have a table where we can actually show you, the tool. But we have a new tool that's free for developers and that will be monetizing, for operations. And the way that tool works, for those of you who've been using Driven, all you have to do is put essentially a jar file on a class path, and the application will be automatically instrumented. And so the application will send telemetry data to our backend. So we're running a backend software as a service on the cloud. That again, that's free for developers, and we are providing also a hosted version for companies who want to host that themselves. And what it will allow you is like when you actually develop or when you run, you will be able to see your graph. So in that case, it's a very simple graph. It's a bit difficult to see because it's a screenshot, but you can see at the left side there's a tab, and then we have a few, pipes after that, and I've just clicked on one of them, and it's essentially showing here that it's a function that's using a parser. It's showing where it's being used, in the source code, and then it's essentially explaining that it's getting a line, and it's going to parse that into, those 5 fields, we have. And then beyond those views that you can have, we also have a pretty interesting view, and I'll show you a more complete example later on, but we have what we call a performance view. So again, this is a very simple example here, only a few pipes, but you can actually see how the main graph on the top will be broken apart and actually mapped into individual map and reduces. And again, for much complex workflow, you'll have much bigger element graph, right, based on what's being done. But here you can see that it's basically broken apart, and then you can start looking at the number of slices, for each mapper reducer, and you can start getting performance information, and you can start, adding counters and stuff. So it's kind of like a great tool as you develop to get a lot of insight as to how your application is developed and how the application is performing. And likewise, if you have exceptions, you can actually go back, take a look at it, click on the exception, and so forth. So now I'm going to talk a little bit about PMML and cascading and how the two kind of fit together. So PMML is essentially a standard, for XML standard for predictive model markup, right? Hence the name PMML. So it's a specification, right? It's not an implementation of a model, it's a specification. So the way it works is that you will develop essentially a model in SAS or MicroStrategy and so forth, and you will have the option of saving that model using that essentially, PMML standard, and that will save, the model, right? And there are essentially two parts to it, right? There's the producer's part that's being used for applications that are creating the predictive models, and then there's the consumer part for the application that essentially read, consume, and execute the models. There are essentially a number of models, covered, by the PMML specification. So you can see some of the popular ones like, decision trees, regression, and so forth. And you have also the notion, and this is something we support in cascading, you have the notion of ensembles where you can start mixing and matching, several of those models, to actually improve, accuracy. And there's basically a number of companies, behind, including, the big ones like in the analytic, space that are providing support for PMML. And I'll actually be doing a demonstration using R and essentially creating a simple model and saving that, using R. So if you look at what you have to do in order to build and essentially run a model, there are kind of two parts, right? There's the training part where a model producer will ingest prepared data, right? So you first have to prepare the data, and typically you use some kind of ETL technology, right? And you'll basically, send that, to the model producer after it's been prepared. And then in turn there, you'll basically, explore the data, right? And then after, a number of variations, you'll create a model using essentially machine learning algorithm, whether it's like, linear regression, clustering, or whatnot. And then in turn, what you have is a PMML model. And once you have that PMML model, what you can do now, you can do the scoring part, right? Which is again, now in that case, you get new data that you want to score based on your model. So again, you have, to just, prepare that data, right? And then you'll basically have a model consumer, that based on the PMML model will execute, the correct algorithm and score, the new data based on that model, right? And typically after that, you'll have some post-processing where you want to do some measurements, and improve the model based on like, how well, the score was. And this is typically where pattern fits in, right? So pattern is basically there as a model consumer, right, to be able to score models, right? It doesn't work on the training part, but it does work on the scoring part. The way you will create a model in R, so this is some simple code, and I'll be running an example for that. So in that case, we're going to use, as an example, we're going to use a random forest model. So we're essentially getting some data, and we're going to create, essentially an ensemble of like 50 trees, right? And at the end of the day, so we are like doing a prediction also on it to kind of execute, that. But in the end, what we do is like we save, the data at the very bottom. What we will do is basically save, the data, export, that to PMML. So it's kind of like the save XML command, right? You can just save your model there. And in the end, what you get is something like that, right? You basically get a model that in that case is a random forestry model, and then you'll basically get all your 50, trees and in there, right? And you'll get your 50, decision trees. If you actually zoom in, you'll see, for each tree, you'll see, the substructure, and how it composes. And I can show you that when you run it. And from a pattern standpoint, all you have to do is basically load up that model, right? So it's pretty easy. So we have a PML planner, right? And you basically input that with, the PMML, model, right? And then you basically essentially just score the model, creating a new variable, right, predict, that will basically classify the data in that case. So that's kind of all you have to do in order to basically be able to reuse, and score the model with new data. And like everything else in cascading, right, at the end of the day, all we produce is a jar file, right? So any cascading application is a jar file, right? And you can even have one cascading application that encompasses, lingual, cascading and pattern code, right, in just one jar file, right? And then in the end, the way you run the jar file is just using the Hadoop, jar command, right, with cascading, jar file. And in that case, we're basically saying we're going to use, data file, right, called, iris.rf.tsv, and we're going to basically put it under output classify, and we're basically going to use, the data iris, RF model. So I'm reusing some of the examples that are actually available in the pattern project. So if you go online, you'll be able to see, the example, available. And this one is a pretty simple example for classification based on iris data. That's kind of like a public, sample available. And what it does, it looks like classifying, flowers, iris flowers based on the petal and sepal width and length. So you only have 4 attributes, and then based on that, you can like determine what species it is. So now going back to kind of pattern, these are the 5 algorithms, we already have implemented. So we don't have a full coverage, of the PML model yet, but we have those 5, algorithms implemented and available. So hierarchical clustering, K-means, linear regression, logistic regression, and random forest. And I will be showing you, random forest as an example. And and algorithm, can be ADX extended, right? It's basically open source, so it's easy, to kind of add stuff over time. And probably as a company, we'll be, developing more and more over time based on demand. So the way it works basically in cascading, right? So what you can do, going back to the training and the scoring. So again, pattern is only used for the scoring part, right? But you can use, a lingual or cascading to actually prepare the data, right? So basically, if you want to, clean the data, parse the data, right? Do whatever in order, to be able to prepare the data, you can use, the lingual, which is the NZ-SQL API, or cascading, which is basically the programmatic API, right? So you can use that to help, prepare the data. And then you'll use basically a tool like, again, SAS, R, that will create, the model and export the model. And then once you've done that, then the scoring is all about, again, doing, maybe pre-processing based on the new type of data you have, data preparation, and then using pattern to essentially score the model, and again, post-processing. And I'll be showing you an example of that in a minute. So kind of the idea, it's kind of like, single model architecture, right? This is kind of something that's interesting for a few customers, is that you can actually create a combined application using, cascading, family. And in the end, you can do a complex data process across, like one app, or one application. So you could use, lingual to do the ETL, if the ETL is simple enough. You might have to do, advanced, more advanced, data preparation. And then you can use, pattern to just, score the models. So, and again, all the stuff we have is open source. So we believe you can reduce on cost for like, the ETL part and also the scoring part, right? Because when you want to start, scoring very large data models, and when you want to create ensembles of models, to improve accuracy, right? Then it becomes very costly, right? With some of those, platforms out there. So now you can do that, in open source on top of Hadoop. And this is kind of the notion of being able to score data in experiment at scale, right? Because you get a Hadoop platform, you can get a pretty large cluster. So now you can run a lot of experiments, you can run a lot of variations of your model, you can run different models using assembles, right? And do basically averages, right? And in the end, you can essentially improve accuracy with those models. And you can run things like confusion matrices and root square mean error also using pattern technology. It's kind of the way you will use ETL is very simple also. We have a SQL planner, so all you got to do is basically get the data in, data out, or reading, writing, and then essentially you can execute a SQL statement, right? You can do it that way using Lingual. And then from a pattern standpoint, this is the code I was showing before, which is also really simple, which basically creates a planner, loads up the model, and then you can just score the model. I'm just going to do a demo to show you what it looks like, so hopefully I'll be able to switch back and forth correctly. So I'll put that aside for a minute, because this is what we're going to use to look at the stuff. So I'm first going to generate a model. So I got some simple code here that I got to grab, if I can find where it is. Let me play around with the windows a little bit. So I don't know where you can see it here, but basically in here, I'm going to create, in R, a model. So I got all the libraries, functions available. Then we're going to basically read the data set, the iris, data set, the one that's open source available. We're going to essentially create, a training, and training model, right? Training set. And we're basically going to create our random forest here. Then we're going to print, the fit there and do some nice graph to show it what it looks like. And then in turn, we're going to save it essentially here to a PMML model that we'll be looking at. So I'm just going to go copy and paste that in R. I'm going to find the R console. Then I'm going to essentially run that, right? So now what it did, it basically produced, it actually, in that example, it scored that data, and it also produced, the PMML model, right? And displayed a nice graph. So now we can look at the PMML model, which is actually right here. So we can open it up. Move it here. And here you can basically see that this is basically what we just generated, right? Which in that case is basically the random forest tree. And we basically have the 5 fields we've been using, and you basically have going to have inside those 50 trees, decision trees in there, right? Based on the data set. So you can have all that, right? And basically this is what we're going to import in cascading to actually do scoring, right? So you have that for the all 50 entries. So I'm going to close that. And now that we've generated the PML model, all we need is basically import the model. So I'll show you the code that we're running, which again is available, but I'll show you what it looks like. So we're just going to basically have a very simple code, to kind of load it, right? And then basically, score it, similar to what I was showing before. I'm going to bring the window to run it using Hadoop Georgia. And what it's going to do essentially is going to execute, that pattern, demo, right? So it's going to create, a plan based on that, and it's going to translate that in cascading, code, and it's going to execute that on the cluster. So in that case, we're basically going to get the data set we're going to score, the TSV. We're going to put it under the output classify, and we're going to use the model we just created. So we're going to execute that. And if all is OK, it should be executing that on the cluster right now. So it's going to take, I don't know, maybe a minute, maybe less, to actually do the loading and basically scoring. And while it does that, I can actually go and look at the console in real time using the driven tool. So we're going to let it run here. And I'm going to bring that up here while it runs. And here you can see that this one is actually running right now in the pattern demo. And it's actually in the process of being scored, and it did already being scored, so it just completed, right? And in that case, we can look at the physical plane, which in that case, it's a big graph with the 50 decision trees, right? Like that. And then we can also what it looks like from an execution standpoint and what the mapping looks like, again, because this is very simple. There's basically that kind of representation, right, with pattern. And just showing you a little bit more on driven, we could model different flows, for instance. This is a demo we have over there also running. We could model more complex flows. And with something like that, for instance, right, I can look at the physical plane and I can pick one subflow, right? And I can actually look at the graph and then I can see how the graph breaks down in terms of basically, set of mappers and reducers, and I can click on every single element to get the ID, and then I can get the slice information, add the Hadoop counters and whatnot, right? So that will help you basically as you develop, the apps, right? But coming back to our model, so this is it. So this is pretty simple, right? So that's the way you basically, do it in cascading. Which is what we did, right? We generated our model. So in that case, we created a new one, right? But you could have reused, one you already have. Then you can take a look at the PMML model, and then you can run it, to essentially score. And you could look at the score data on the Hadoop cluster and verify, the output. So the key takeaways, I think I'm being a bit early, right? But the takeaways is be able to reuse existing investments, right? So I think this is something that's pretty interesting in pattern technologies, that you don't have to reinvent the wheel, right? So you can basically rerun, your existing models. And not only that, but you can basically tie them in a bigger, broader, application, right? Where you basically have leverage, existing skill sets, right? So now you have, on one hand, a model that was already built, but now you can start using, Java, Scala, SQL, right, to basically be able to score that model. And you can essentially have the team collaborate on a single model. And again, in the end, the application can be a single jar file that you deploy on the cluster, and you can use a single tool to visualize it, manage it, and monitor it from an operational standpoint. That's kind of what I have. I'm done a little bit ahead of time. If you're interested, I can take a few questions and answers. As I said, we'll also have a table, in the exhibit area. We have a number of demos, running. And I'll be happy to show you more detail there if you're interested in drilling down into specifics for the application or the framework. Thank you. Any questions? Yes.
How are you going about doing that? Are you just, in your create flow, are you just assembling them a set number of times, or is there a looping construct?
Sorry, can you repeat the question?
I'm trying to see if there's a looping construct in cascading, or if you're just connecting them in your flow depth a set number of times to be repeated.
Yes, no, we don't have. We don't have a concept of looping in cascading. You'll have to, there are a few ways, you could do that, right? But there's no notion of loop because you have to create a graph. I mean, when you create a function, a pipe, you can create a custom function. Within the custom function, there's a possibility of, redoing or re-incrementing multiple times. But we'll have to talk about what you're trying to do and see if this is the right way to do a loop or not. And then you can also create, sub-assembly that you can reuse, right?
I've tried sub-assembly, but I can't figure out how to do it.
Okay. So if you're telling me if you want, we can take it offline, and I'll show you ways it can be done. Yeah. You.
I have a question. So you mentioned that we created a model using R.
Yes.
We applied that using pattern for scoring.
Yes.
How do we guarantee that we do the same kind of transformations while scoring? The model is built based on some transformations, right?
Yes.
We need to do similar feature transformations even during scoring. How is that guaranteed?
So in that case, we're running random forest, right? So basically, the implementation of a random forest algorithm is basically done in cascading, right? So what you do is that basically you do the scoring, right? So we have an implementation of the random forest. So
So it should be the same data
Yes.
that was used for the modeling.
Yes. Yeah. You need the data to be prepared accordingly. Yes. I'm sorry.
Have you done anything around using the PMML models for the logistic regression to classify images? So I wonder, have you done any PMML model that you could use the logistic regression to classify images instead of text files?
We have not, but at the same time, it's open source, so there are lots of companies that are using some of the, the tools in a number of ways, right? That we don't know, about. I know there are companies, doing an image processing and cascading. I don't know of any using pattern, but I guess everything can be done, right? Yeah. Very good. Thank you very much. I'll be available now, for the next, 15 minutes, and then I'll probably be most of the time at our booth over there. So if you guys want to stop by and chat, you're more than welcome. Thank you.